This is going to be the last video on gross premium reserves in contingencies in actuarial mathematics. In subsequent videos, I'll be covering mortality profit. Okay, so in this video, I'm covering the recursive relationship between annual reserves, and then I'll cover a special result. Okay, so far we've dealt with prospective calculations of reserves and retrospective calculations of reserves, one looking forward, one looking back. But there's actually another way to calculate the reserves, and this is a recursive method. So what this actually requires then is for us to have the reserves in one of the years, and then we can actually calculate reserves in subsequent years. Obviously then with assumptions again about premiums, expenses, benefits, and terminal expenses, mortality, interest, etc. But that's no different to prospective and retrospective reserves. We also have to make those same type of assumptions. So here's the formula. So if I need my reserve in time t plus 1, and I have this reserve at time t, this is TV over here, then plus G, which is my gross premium, minus E, my renewal expense, I take that 1 year forward in terms of the time value of money, and then I subtract from that Qx plus T times by S plus F, so S plus F being the sum assured or the benefit plus the terminal expense. This should equal to P x plus t times by t plus 1 v. Okay, and this is the recursive relationship. So let's understand this intuitively so that we don't have to memorize this thing. So essentially what I'm saying is, on this left hand side, I have the reserve at the start of the year. Then I increase my reserves by this premium, and I decrease it then by the renewal expense, and then I'm dealing with everything now at time t plus 1, so I take it forward a year, this lump sum, which is my initial reserve plus my premium minus my expense. I take that forward by 1 year in terms of the time value of money. And then now I'm sitting at time t plus 1. Now the cash flows that could happen at t plus 1 is this person dying within the year, and then me having to pay out a sum assured and a terminal expense, which is this S plus F, okay? And I will pay out this S plus F with probability Q x plus T. So if this person dies, which happens with probability Q x plus T, so a life age x plus T dies within the next year. So if they do die, then I pay out this amount, S plus F. So the expected amount I'm paying out is the probability times by that value. So I have this lump sum that gets increased to the end of the year, and then at the end of the year, I pay out this amount. Okay, then that should leave me with some number at the end of the year. And what is this number at the end of the year? This number at the end of the year is the amount of money that I'm moving forward into the next year with. And that is the reserve at the beginning of the next year, this t plus 1 v. But then again, I started at time t, so I'll have this t plus 1 v with probability x plus t. So if they do survive to the end of the year, then I'm going to need to have these reserves. I'm going to need to hold those reserves, and so I multiply it by p x plus t. Okay. So another way that you could think about it is, if I take this to the other side of the equation, then I say, after all of this has happened, I'm left with a certain amount, the reserves for the next year, and if I subtract those reserves off with the probability of them surviving, I should be left with no money, which is why then the right hand side would be equal to 0. Okay, so we can then also rearrange this to get another formula, which is also useful. So it takes this form. Let me quickly write it and explain how you get here and then why it's useful. Okay, so essentially what I've done here is I have divided both sides by px plus d and then done a little bit of rearranging, and I end up with this. Now, this is useful because for the same reason as before, you can similarly logic it out and intuitively it makes sense. All your cash flows from the start of the year, you take that to the end of the year, and then these are all potential cash flows at the end of the year. I pay out a benefit, I pay out a terminal expense with probability qx plus t, and then I also have this t plus 1v. So this is now where the interpretation differs, and this is actually a good segue into mortality profit. So this thing here is known as the sum at risk or death strain at risk. So let's understand that. Why is that? But I'm not going to spend too long on this because I'm going to cover it in subsequent videos. So just briefly, death strain at risk is looking at this amount outflow that I'll pay if this person dies versus the amount that I would have had to reserve for them or keep in reserves if they have stayed alive. Okay, so then the difference between those two, so the dying amount that I'm going to pay out versus the living amount that I would have to set aside, so essentially two outflows, is this difference where the dying amount subtracted by the living amount should give me the death strain at risk. In other words, the amount that this insurance company is put under strain if a death were to occur. That's the way I like to think about it. Okay, so death strain at risk there. Okay, so if I take all of these cash flows to the end of the year, and then this death strain at risk is what the insurance company will incur if this person dies. So if they die, then there's that outflow, and then I should be left with just the final reserve t plus 1v. Okay, because remember, this death strain at risk is the difference between the two. So if I'm subtracting here the difference from this accumulated amount, then I should be left with just the t plus 1v, not accounting for probability. Okay, so if this is more difficult to understand, which I suspect it will be because it was for me as well, especially because of this death strain at risk, then try and remember it with this formula here. Okay, and another way that you could try and remember it is you could just accumulate all these ones and take this to the other side and have it as a plus over there, and then you say that if the person lives with probability x plus t, then that's the amount that my left hand side must equal to. But if they die with qx plus t, then this accumulated amount should just equal to the s plus f thing. So that's essentially another way of thinking about it. So I've given you a few ways to think about it. Pick whichever one makes the most sense to you. Okay, now, next thing quickly before I go on to this special result is how we result in a profit. Okay, so we can only result in a profit for a particular year t if the bases within my calculations differ. So what I mean by this is if the basis that I use to calculate my premiums differs from the basis that actually happened in reality, so the set of assumptions, what they actually turned out to be, or the set of assumptions that I used to calculate reserves, which is often different to my pricing basis, my basis that I use to calculate premiums. So if any of these bases differ, then I can end up with some type of profit. Okay, and this profit will equal to TV plus G minus E times by 1 plus I, and then minus QX plus T into S plus F, and then minus here PX plus T times by T plus 1 V. Okay, so essentially accumulating all the cash flows at the start of the year to the end of the year, and then I pay that out if they die, or I pay that out if they survive. And essentially that's not really a payout, but I set it aside, so I still think of it as an outflow for this year. Okay, alright, so let's move on to the special result then. Okay, so the point of this special result is to make calculating reserves easier. So Okay, so without explaining, let me just go and prove it, and then I'll explain it afterwards. So we start off, I'm going to do this for whole life assurance, and this special result holds for a few other ones, which I'll say after I've done the proof, and then it doesn't hold for any of the other ones, but I'll get to all this explanation in a moment. So for a whole life assurance I'm dealing with now, if I were to price this policy, I would have the amount that I'm paying out equal to the premium times by this annuity factor. Okay. Now, I need to eventually end up with reserves. So the reserves for a whole life assurance policy, if I do it in terms of a prospective calculation at time t, then I take the future outflows, the expected future outflows minus the expected future inflows, which is the premiums. Okay. Then, now, what you notice is from this line, I can rearrange to get P is equal to AX over A dot dot X. Alright? So, I then substitute this in for P. And what I then end up with is AX plus T minus AX over A dot dot X times by A dot dot X plus T. Alright, now my premium conversion formula means that I can change this assurance and this assurance in terms of annuities, okay, in terms of life annuities. So this becomes 1 minus D A X plus T, this one here, and then this AX becomes 1 minus D AX, and then I still keep those two terms there, AX plus T over AX. Okay, so now it's just a matter of simplifying everything. So it turns out that when you do simplify this, you end up with 1 minus AX plus T over AX. Okay, so to quickly see why that's true, if I were to distribute this into this brackets, I would get this into the 1, which would just leave me with this term, the minus that. Okay, then if I distribute this into the second term here, negative times negative is a positive, then this term and this term cancel, and I'm left with plus D times by that annuity factor, which cancels with that one, and then all I'm left with is the 1 and minus that thing. Okay, so you can if you don't believe me, you can just go and write it out yourself, but you will get to this result. Okay, so this is now the special result. The reserve is equal to this. Now this is very helpful because it means that you don't have to go through this long process of actually solving yourself, because what you would have to do is, if you wanted to calculate this reserve, you'd have to write out either your prospective or retrospective formula, or if you had the previous year's reserve, your recursive formula, and then you would have to go and calculate your premium using this, substitute in your premium, and then go calculate the reserve. That's a normal way that we calculate reserves, but this basically just jumps right to here. And the reason why we can jump there is because things cancel neatly using these premium conversion formulas, which is why we end up with the special result. Okay, so this special result holds for whole life assurances. So let me just quickly write down things it holds for. It holds for that. It holds for that where the death benefit is payable immediately on death and where the premiums are payable continuously. So this is where the death benefit is payable at the end of year of death and the premiums are payable annually in advance. Then it also holds for TVXN. So this is the reserve at time t for an endowment assurance where the death benefit is payable at the end of year of death and the premiums are payable at the beginning, so annually in advance. Okay, and then it also holds for this here, so an endowment assurance where the death benefit is payable immediately on death. Sorry, I don't know if I said immediately on death for here, but this was supposed to be the end of the year of death for this particular case. But here it's immediately on death, and then the premiums are payable continuously. throughout the term of the contract. Okay, so this special result holds for all of these things, and it does not hold for any other cases. So for term assurances, doesn't hold. And any other things that you can think of, it doesn't hold. If you have an endowment assurance, but the premiums are payable annually in advance, but the death benefit is paid immediately on death, then it still doesn't hold. Okay, so it only holds for these specific 4 cases. Okay, that's everything I wanted to say in this video. If you have any questions, leave it in the comments down below. Thanks for watching.